So today we are going to revise the electricity chapter. Okay, one by one we'll see the concepts. First concept is what? Current. When we talk about current, I is equal to what? Q by T. Okay, so current is nothing but the rate of flow of charge or charge flowing per unit time is called as current. Here Q is what? Charge, T is what? Time, and I is what? Current. Yes or no? Current or electricity. When we talk about the SI unit of charge is what? Coulomb, time in second, current ampere. So if 1 coulomb of charge flows for 1 second, then current is said to be 1 ampere. They may ask you define 1 ampere. So we can say that 1 ampere is that amount of current is said to be 1 ampere if 1 coulomb of charge flows through the conductor for 1 second. Is it clear? Next, we talk about electric potential, or simply we say potential. Just potential, it is represented as V. So when we talk about the potential, we talk about the potential of a particular point. Okay, for example, let's say A is a point. I want to know the potential of this point A. So what we are going to do, we are going to move a charge q amount of charge which is there at infinity. So when you move the charge q from infinity to this point, we have to do some work right now. So that amount of work done by charge is called as potential. Okay, so we can write V is equal to what? W by Q, where W is what work done and Q is what? Charge. If 1 joule of work is done to bring 1 coulomb of charge from infinity to a point, then potential is said to be 1 volt. 1 by 1 is what? 1 volt. Okay, there is a little difference between the electric potential and potential difference. Okay, when we talk about potential difference, so potential difference PD we are writing in short. Here what happens, a charge is moved from one point to other point. Suppose Q charge is there at A, I want to move this Q charge from A to B. So to move this charge Q from A to B, we have to do some work right now. So that amount of work done to move a charge from one point to other point, that is A to B, is called as potential difference. Okay now, so here amount of work done, SI unit is what? Joule only. If 1 joule of work is done to bring 1 coulomb of charge from one point to other point, then potential difference is also said to be 1 volt. So SI unit of potential and potential difference is same. Is it clear? After this, we have to know Ohm's law. See, Ohm's law states that at constant temperature, potential difference across the ends of the conductor is directly proportional to the current passing through its end. Or we can say like this also, this is the conductor. When V is applied across the ends of this wire, so at constant temperature, T, okay, V is directly proportional to I. When you remove the proportionality, you have to put a constant. That constant is what? R. So V is equal to what? IR. This is the expression for Ohm's law. Here R is called as constant of proportionality, called as resistance. R is nothing but a resistance. So from here R is equal to what? V by I. Let's take the potential difference 1 volt and current 1 ampere. So 1 by 1 is what? 1 ohm. The symbol of ohm is like this. So resistance of the wire is said to be 1 ohm if 1 volt is applied across its end and carries a current of 1 ampere. Yes or no? How will you define resistance? Actually, resistance is nothing but the opposition offered to the flow of charges. Is it clear? So they may ask you what is resistance. Next, we'll discuss about the factor which affect resistances. There are generally 4 factors. This question also may be asked for 2 to 3 marks. Okay, so factor affecting resistances. Factors affecting resistance. So generally there are 4 factors. How many factors are there? 4 factors. First one is what? Length of the conductor. Length of the conductor. How it is related? Resistance of the wire is directly proportional to the length of the conductor. It means if the length of the wire increases, resistance also increases. Is it clear? Next factor is what? Area of cross section. Okay, so resistance of the wire is inversely proportional to area of cross section. Area of cross section, when we talk about, means thickness. Okay, for thick wire less resistance, thin wire more resistance. Is it clear? Next factor is what? Temperature. Here also resistance of the wire is directly proportional to the temperature. If the temperature is more, resistance is high. Okay, why? What happens when you when you talk about the conductor? So in the conductor, electrons will be in motion right now. So once you heat the conductor, okay, so collision between the electrons increases. So randomness increases. If randomness of electrons increases, so what will happen? It offers more resistance to the flow of charges. Is it clear? Okay, now, and the last factor is what? Nature of material. Last factor is what? Nature of material. Okay, for conductor it has less resistance, for insulator it has more resistance. Is it clear? Okay. Now after this we should know combinations of resistors. How we are going to combine the resistors. Okay, so first one is what? Series combination, parallel combination and mixed combination. 3 types of combinations. Problems may be asked in the board examinations. Okay, so first we see resistors and series. Resistors in series. So let's take this is one resistor R1 and another resistor R2. If 2 resistors are there connected in such a way that one end of each resistor is connected to one end of other, that's all. Such type of connection is called as what? A series connection. This is called as what? A series connection. Is it clear? What you should keep it in mind in series connection. See, if V is applied, current is source of energy, actually source of current. So I current will start flowing from this. So same I current will flow through R1, same I current will flow through R2. Here in series circuit current is same. Try to understand. What is same? I is same. So when I1 passes through R1, there is a potential drop across this. That is V1. Similarly, whenever I current passes through R2, there is a potential difference or potential drop, we say, across R2, that is V2. In this circuit, V is equal to what? V1 plus V2. In series combination, if you want to find the equivalent resistance, RS is equal to what? R1 plus R2. Is it clear? If 3 resistors are there, so R1 plus R2 plus R3. Is it clear? Okay. Next, we talk about resistors in parallel. Okay, generally this is very important. Resistors in parallel. See, if there is a resistor R1, another resistor R2, if one end of this is connected to one end of this and other end of this is connected to other end of this, end to end connections are called as parallel connections. Is it clear? Here we are connecting a source of energy, that is V. Okay, here it will give a I current. So when we talk about resistors in parallel, okay, see one end of this R1 is A, other end is what? B. One end of R2 is A, other end is B. Similarly, one end of this battery or cell is A, other end is what? B. So what is same here, children? Potential difference is same. Potential, one second. Potential difference is same. Potential difference is same. Difference is same. Here current divides, children. He try to understand when I current starts from here. Okay, here two different paths are there. Okay, and different values of resistors are there, R1 and R2. So here the current through this is what? I1, and current through this is what? I2. Here current divides. So what we can write? I is equal to what? I1 plus I2. Okay, you will study in higher standard. There is one law also called as Kirchhoff's current law. Okay, KCL. According to this law, at the junction, the sum of entering current is equal to sum of leaving current. So at point A, children, what is the entering current? Can you say? I is there. And what are the leaving currents? I1 and I2. So you will learn this in second PUC and grade 12th. Okay, so according to that also we can say. For ICSE students, you should know. Okay, sum of, at the junction, okay, the sum of entering current is equal to sum of leaving current. So I is the entering current and I1 and I2 are the leaving currents. From there also we can see I is equal to what? I1 plus I2. Is it clear? Now what happens in this case? 1 by Rp, equivalent resistance, 1 by Rp is equal to what? 1 by R1 plus 1 by R2. Is it clear? So reciprocal of equivalent resistance, reciprocal of equivalent resistance is equal to the sum of reciprocal of individual resistance connected in parallel. Okay, na? So if you want to solve this in short, we can write 1 by Rp is equal to what? Take the LCM. LCM will be what? R1, R2. So R1, R2 divided by R1. So R1 get cancelled, we will get R2. So here R2 plus this divided by R2. R2 get cancelled, we will get R1 into 1. So directly we can write Rp is equal to what? R1, R2 divided by R1 plus R2. We can use this for short tricks. Okay, if the two values of resistors are connected in parallel. Okay, is it clear? For example, you see, let's take there is a resistor 6 ohm and another resistor 8 ohm which are connected in parallel. So how we are going to solve? Directly Rp is equal to what? R1 R2 divided by R1 plus R2. Yes or no? So R1 is 6 ohm, so 6 into 8 divided by 6 plus 8. How much you will get? 6 into 8 divided by how much? 14. Yes or no? So this is 4 times 4 2 ja and 7 times, right now. So 24 by 7 ohm. Okay na? 24 by 7. Remember one thing, the value of equivalent resistance in parallel will be always less than whatever the values of resistors are connected. So approximately you will get a 3 point something, 3.4 ohm approximately, you see. Okay, so is the 3.4 less than 6 and 8? Yes. Okay, what will happen if the two equal resistance are connected in parallel? Let's take this is R and another values resistors R is there. Okay, so directly you have to remember R equivalent is equal to R by 2. Directly you can write. Substitute, you can check once also. Okay, as we know that R1, Rp is equal to what? R1 into R2 divided by R1 plus R2. Yes or no? So two R1, R2 both are same. So we can write R into R divided by R plus R. Okay, so it is what? R square by 2R. So R square and this get cancelled. So Rp is equal to what? R by 2. This is also very useful when the circuit is lengthy. In the board exam, they will give you questions like 10 ohm resistors are connected in parallel and 4 such connections are connected in series, and that combination is connected to a 5-volt battery. Okay, the question is like this: 10 ohm and 10 ohm are connected in parallel. Is it clear? This is a board question which has been asked, and again this such 4 combinations are there in series, means again 10 ohm and 10 ohm is there. Okay, similarly one more time, 10 ohm and 10 ohm. Okay, similarly one more time, 10 ohm and 10 ohm is there. Okay, and in the entire combination is connected to a 5-volt battery, let's say. The data may be different. So find the value of R equivalent and what is the value of current. Okay, can you solve such questions? Very simple. See, 10 and 10 ohm are in parallel, yes or no? 2 equal resistance are in parallel. So what is the equivalent resistance? 5 ohm. Rp is equal to what? R by 2. So this is 5 ohm, yes or no? Similarly this will be 5 ohm. Similarly this will be also 5 ohm. Again this will be 5 ohm. Okay na? 5, 5, 5, 5. And this is connected to what? 5 volt. Okay, 5, 5, 5, 5. They are connected in now series. These are our series only. 5 plus 5 plus 5 plus 5. How much is R equivalent? Tell me. R equivalent will be how much? 5 plus 5 plus 5 plus 5. 20 ohm. Okay, and what will be the value of current? I am writing here. Current will be equal to V by R equivalent. So V is a 5 and R equivalent is 20. So 5 1 ja, 5 4 ja. So 0.25 ampere will be the answer. Yes or no? We will discuss later some more problems. Is it clear? Okay na? Next concepts, I am going to discuss some formulas are there for related to the power, okay, and the energy and the heating effect of current. Let's see one by one. First we talk about electrical power. Electric power. So power is a P. P is actually power is equal to voltage into current or potential into current. Okay, power, when we talk about power definition, it is defined as the rate of doing work. Okay, what is power? The rate of doing work is called as power. SI unit is what? Watt or volt ampere. Okay, SI unit of power is what? See, when V is let's say 1 volt and current I is equal to 1 ampere. So power is equal to what? 1 volt into 1 ampere, that is equal to 1 watt. So SI unit of power is what? SI unit of power is watt. Is it clear? We are representing as capital W. Okay, SI unit of power is what? Okay. I will clear it. Okay, I will clear it. Another formula for power is there. P is equal to, we know that V into I is there, yes or no? And we also know that V is equal to what? IR. If you substitute this value, so what we can write? P is equal to IR into I. So what we can write? I square R. So if current and resistance are given, so we can use this formula, I square R. Is it clear? Okay. Okay. One more formula you should remember, children. See, P is equal to, you know that V into I is there, and from Ohm's law we can write I is equal to what? V by R. Yes or no? So P is equal to, we can write V into V by R, or P is equal to what? V square by R. If the potential difference and resistance are given, we will use this formula, V square by R. Very, very important. Being a good student, you should know all the 3 formulas for the power. Okay, getting up? Okay. Next concept is what? Energy. Okay, energy is actually power into time. Power into time. So E is equal to what? P into T is the formula. And SI unit of energy is what? Joule. SI unit of any form of energy is what? Joule. Okay na? So when the power is 1 watt and time is equal to 1 second, so we can write energy is equal to 1 watt into 1 second, that is equal to 1 joule. 1 watt second is also called as 1 joule. Is it clear? Okay. They are asking in the exam, define 1 kilowatt hour. Okay, this is the board question they will ask you. Okay, 1 kilowatt hour, what is it? So see, we know that energy is equal to power into time. When the power is 1 kilowatt, children, okay, and time is what? 1 hour. So we can write energy is equal to 1 kilowatt into 1 hour.